up like our teeth are falling out. We got spots on our back, so give it up and shout. We got scurvy, we need some vitamin C. We got scurvy, we need a lemon tree.
Alright, we're going to talk about scurvy in this video and why the treatment for scurvy is some vitamin C. And so, in class, we've talked about collagen. So just a reminder, collagen is a filamentous protein, or a fibrous protein, so it's long and cylindrical. It acts as the reinforcement of our bones and our connective tissues. It helps us, stay structurally sound. We know that it's a helical structure. It's not an alpha helix, so it's a left-handed helix. And we know one of the reasons why it can adopt the structure it has is because it has proline, glycine, and then hydroxyproline. And the big reason, the big thing why we care about vitamin C and why we get scurvy is because of this, hydroxyproline. And so what we're going to see now is how we hydroxylate our proline, and then how we can, so that we can make our collagen the way it needs to be made. So, in our protein, we have a proline residue. This type of modification that occurs on the proline is known as a post-translational modification. Translational modification. And what that means is that this modification to these residues or to this protein occur after the translation of the protein. So this protein has been transcribed into RNA, and then it's going to be translated into protein. But the full translation occurs, the full protein is made before this modification is placed. And so it's known as the post-translational modification. And so what happens is we have our proline residue, the enzyme that performs this activity, we're not going to worry about its name right now, takes a proline residue plus this molecule. We will see this again when we talk about the citric acid cycle. And this is alpha ketoglutarate, right? Alpha ketoglutarate. This enzyme uses iron, and what we're going to do is we're going to add a little bit of oxygen into this reaction. And so what we're going to make two things. Actually, we're going to have 3 different products. So we're going to have our proline, but instead of just proline, we're going to have hydroxyproline. And this is exactly how it looks. You guys should be able to identify or even draw hydroxyproline because all you're doing is adding a hydroxyl group. So this is for hydroxyproline. We're then going to get this molecule, which is known as succinate. So again, we'll see alpha-ketoglutarate, we'll see succinate when we talk about the citric acid cycle, plus, I'm going to do this in a different color so that we can see it, plus carbon dioxide, right, again, so why we breathe out the way we do. Now, the problem with this is when this reaction occurs, the iron of this enzyme becomes reduced. And so when it becomes reduced, it turns into Fe plus 3. It becomes oxidized, right? It becomes oxidized. And so when it becomes oxidized, it becomes Fe plus 3. So, how can we help this iron out? Because at Fe plus 3, it can't function. We can't do this. And so what can we do? What we can do is have a separate reaction going with alpha-ketoglutarate. So we'll take alpha-ketoglutarate, so alpha-ketoglutarate plus oxygen again. Oops. Except this time we're going to do this. We're going to have this molecule. This is a ascorbate. Right? We get ascorbate from vitamin C. And so what we can do is when we have our iron is oxidized or when we want to keep that iron reduced, what we can use is ascorbate to help us with that. And so we want to keep it in the iron plus 2, but yet it needs to do this type of reaction. And so what we get back is very similar products to what we saw before. So we get succinate plus a CO2. Except this time we're going to get this. Oops. Oops. Let's draw that to the carbon. We're going to get this, which is dihydroascorbate. When this occurs, this iron stays at plus 2. And so we can prevent this iron becoming iron plus 3 because we have the ascorbate. It's an uncoupled reaction, right? So these are two separate reactions. The normal reaction is what we saw before, where we make the proline, but the iron plus 2 becomes iron plus 3. And so, uncoupled from that, in the same enzyme though, it can do this. Taking alpha-ketoglutarate to succinate with oxygen, but we can use ascorbate. And when we use vitamin C or ascorbate, the iron stays at an iron plus 2, and this is very important. This is why, if we don't have this type of reaction, if we don't have enough ascorbate, all of that iron will turn into iron plus 3, and then we get scurvy. If you have any questions about this, please come and ask me, and I'd love to go over it with you.